A very good afternoon to everyone who's watching our discussion today. And thank you for joining us on our panel series where we interview experts in fields such as digital manufacturing and cybersecurity. My name is Dr. Susheem Kanwar, and I am a postdoctoral researcher at the NYU Tandon School of Engineering. Before we begin, first let me thank all our sponsors, especially the National Science Foundation, without whose support events like these wouldn't be possible. This webinar will be recorded and uploaded onto our YouTube channel as well as our website. We are joined here today by Professor Adarsh Krishnamurthy, an associate professor in the Department of Mechanical Engineering at Iowa State University, where he heads the Integrated Design and Engineering Analysis Lab. Thank you for joining us today, Professor, and thank you for taking time out of your busy schedule to have a
Sure.
discussion with us. So first of all, if you don't mind, would you like to give a brief introduction about yourself and your work?
Yeah. Um, so I did my PhD at UC Berkeley, and my focus was on manufacturing. So more on design side, design and manufacturing, and my PhD was doing CAD, especially using GPU computing to speed up CAD algorithms. Um, and then I've been continuing that as I joined as a faculty here at Iowa State. Um, so I've been working on digital manufacturing for quite some time now. So uh, I've seen the progress it has happened over the last maybe 15 years or so.
Fantastic. And what would you say is your story? How did you become interested in this field in particular and end up where you are right now?
So I got in. I was always interested in cars. So that's one of the reasons why I took mechanical engineering. And then uh, I by chance started working on CAD, and that really was something that I wanted to do. So I applied for doctoral studies specializing in CAD, and it so happened that my advisor, she was working in both CAD and manufacturing. She worked. She was one of the first people who did algorithms for 3D printing. This was back in like 2002, 2003.
Wow.
And then
Yeah.
that's how I started working on additive manufacturing in some sense. So
Interesting.
yeah,
And how did you dabble into the security aspects of digital manufacturing?
that is more recent. So and that's mainly working with some of the my collaborators here at Iowa State, Dr. Manimaran.
Right.
Govindarasu, and he's a cybersecurity expert, and we had a recent grant together from MXT, which is the Manufacturing Design Institute, one of the Manufacturing USA institutes, and that was on trying to come up with a digital twin that can help with uh, cybersecurity aspects of manufacturing, and uh, we got really interested in using some of the uh, uh, modern 3D printers, um, which are always connected to the internet, and then they don't have any security features. So everything
Mhm.
is communicated without any encryption. So one of my
Right.
students, she was able to hack a 3D printer, like intercept a G code sent to the printer, modify it, and send the modified G code, and the printer didn't know anything was wrong. So
Wow.
yeah,
Wow, that sounds really interesting and
yeah,
I think a very vital field of research in
right.
the upcoming years. And how would you describe a typical day in your line of work? And now, as you said, you recently transitioned to looking into the cybersecurity aspects of manufacturing systems. So, what would you say has been the biggest learning curve for you?
Um, to be more honest, it's more my students who are working on the stuff.
Yeah,
I haven't coded in probably like 5, 6 years now, or more than
right.
that.
Yeah.
But what's at least interesting in in this is that we have been trying to see these large language models, whether they can help with both 3D printing and also cybersecurity. So we make use of LLMs to find errors in G code, and they have been, even pre-trained models have been really good in doing that. And more recently, they have also been able to identify like modified G code very easily. So that's something that we might think might be a good way to deal with this, is like have like a Raspberry Pi or something that runs the LLM model and then verifies whatever instructions it gets. And then once if
Right.
after it verifies it, sends it to the 3D printer. So
And what would you say is the top cybersecurity risk in digital manufacturing today? So, do you think it's at the design stage, or is it at the G code stage? So, at what point in the life cycle would you say is the most vulnerable?
um, the design stage is interesting, but I think that's going to be way more difficult to catch.
Right.
Um, and it'll require like a lot more resources in terms of what is a good design in the first place. So um, on the other hand, like while transmitting, that's easier to catch, and at least that's sort of the lower hanging fruit, I would say. I don't know which is more critical though, because both might end up being equally
Of
important. It's
course.
just that
Of
catching them on transition might be the easier way to do it, or at least that's we have the tools already to build to figure that out. So
Yeah, of course.
yeah,
And going off of what you said, a lot of these 3D printers don't send encrypted signals.
yeah.
Um, so, do you think because of that there is a need for new standards? And if yes, what role you have played or your team has played in establishing those standards?
That's a good question. I don't think I personally don't know of the what standards exist.
Right.
There used to be a standard called MT Connect,
Hmm.
maybe 10 years back, and I don't know
Right.
what happened to that right now. That's for basically connected machine tools. Um, 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 I would say that like the industry adopts these very very slowly. So as I think it's more like the adoption issue rather than the existing of standards issue. So
Of
um,
course.
yeah.
Um, Moving on from that, what would you say is something you enjoy the most about the work that you do and the research that your lab does?
um, I would say the most interesting thing for me is being on the cutting edge of research in terms of new stuff. Like I still can't believe that like ChatGPT didn't exist 2 years back, and we
Oh,
are already using that in day-to-day research and activities way more now. So that's to me is exciting, but it's also on the other side a bit more challenging to keep track of all the new things keep happening. Um,
speaking of ChatGPT and other LLM tools, how do you think the Industry 4.0 or artificial intelligence are or will affect manufacturing security?
um, um, I would let me answer that by broadly by manufacturing, because I feel that they probably will have a larger role in the whole of manufacturing.
Of course.
Like one simple example I can give is if a person is interpreting a manufacturing drawing, they need to be experts in both the design and interpretation of the manufacturing symbols and things like that. Now, on the other hand, if I have a chatbot that could interpret those symbols and provide a natural language interface for a manufacturing engineer, so that could significantly reduce the
Hmm.
the requirement that something might be misinterpreted or wrongly interpreted at the line. So I can think of all these examples where natural language is used at different stages of the manufacturing process itself. So
Definitely,
yeah.
definitely. And in addition to manufacturing security, I mean, you have a lot of research interests. You have worked in scientific machine learning and geometric modeling and computer-aided design. So, on the whole, taking everything into consideration, what would you say are some of your most important contributions in the area, in the field of research?
Um, so I'm more a cat person. So
Yeah.
most of my research has been on what is known as NURBS, or non-uniform rational B-splines.
Right.
So we have developed like GPU accelerated algorithms for rendering NURBS and then dealing with NURBS. More recently, we have developed something called as NURBSDiff, which is basically differentiable spline uh, approximations, and basically come up with ways in which you can use NURBS with machine learning algorithms. And that is work in collaboration with Chinmay Hegde at NYU too. Um, so basically,
Fantastic.
yeah.
Wow, fantastic. And looking forward to how that shapes up and
Yes.
changes the world of digital manufacturing.
Yes, and
So,
one more plug I want to give is we have
oh,
also released something called a Slice 100K, which is
okay,
one of the largest repositories of 3D printing models. So these include CAD models, renderings, and also some metadata, along with the G code file for 3D printing. Um,
amazing. Wow,
so we hope that like data is one of the important things for any machine learning research, and we feel that this open source data would be used by manufacturing community. So
exactly. And how do you see the future of this field evolving in the next 5 to 10 years, let's say?
um, that's what. So you'd probably see a lot more integration with machine learning
Hmm.
chatbots and LLMs. There's going to be a lot more interconnected components, and that means that cybersecurity will also be very, very important. So they have to be included right from the beginning, not just be an
Hmm.
afterthought.
Absolutely.
Yeah.
Absolutely. And finally, Professor, what is one piece of advice you would like to give young professionals entering this field?
Um, so the one thing I tell my students also is like you will. It's very easy to get overwhelmed by all the research that's happening, but I always feel that if you focus on some particular aspect, you'll always find some piece that nobody has worked on, and that's where you'll probably build your contributions on. So I would say just persevere, and it will work out. So
Excellent. Amazing. Thank you so much, Professor.
yeah, thanks. Yeah.
This was very helpful. Thank you.